Hi everyone, welcome to my video. Are you guys ready to learn? If yes, then let's get started. Before we begin, let me ask a quick question. What do you think will happen when I release this rubber band? And why does it move back to its original form? Do you know the answer? Exactly. The reason is because energy is stored while the rubber band is stretched. This is called elastic potential energy. Today, I will explain the elastic potential energy, which is the energy stored in an object when it is stretched or compressed. Elastic potential energy is commonly found in elastic materials such as rubber bands, trampolines, springs, and boats. In this presentation, I will explain the concepts, formulas, real-life applications, and demonstrate how elastic potential energy works. When an elastic object is stretched or compressed, work is done in the object. The work stored as elastic potential energy. As I stretch this rubber band, I apply force to deform its original shape. But because the rubber band wants to come back to its normal shape, it stores energy while being stretched. When released, the stored energy is converted into kinetic energy, causing the rubber band to move back quickly. Elastic potential energy formula. The formula of elastic potential energy is elastic potential energy is equals to 1/2 kx squared, where EPE is elastic potential energy measured in joules. K is the spring constant which represents stiffness, and X is displacement or how far the object is stretched or compressed. This formula shows that the more an object is stretched or compressed, the more energy is stored. Since displacement is squared, a greater stretch results in a much larger increase in stored energy. Hooke's law formula. Elastic potential energy is actually related to Hooke's law, where Hooke's law states that force is equal to negative k times x. The negative sign means the restoring force acts opposite to displacement. This means when an object is stretched, it is naturally pulsed back toward its original position. However, Hooke's law only applies within elastic limit. The elastic limit is the maximum amount an object can be stretched or compressed while still returning to its original shape. If this limit is exceeded, permanent deformation may occur. For example, overstretching a rubber band can damage it permanently. Real-life application. A slingshot stores elastic potential energy when stretched. Once released, the stored energy launches the object forward. A spring inside a pen compresses and stores elastic potential energy. When released, it pushes back. In archery, pulling the bow stores elastic potential energy, which is later transferred into kinetic energy. A trampoline stretches downward when someone jumps on it, storing elastic potential energy before pushing the jumper upward. Energy transformation. The process of energy transformation can be summarized as mechanical work is applied to stretch or compress an object. The object stores elastic potential energy. Then, when released, this energy converts into kinetic energy. Now, before we conclude our video, let us have a practice problem solving. A spring has a spring constant of 200 newtons per meter. It is compressed by 0.10 meter. Find the elastic potential energy stored in the spring. Using the formula, we substitute the given values. The spring constant is 200 newtons per meter while displacement is 0.10 meters. After solving, we got 1 joule, meaning the spring stores 1 joule of elastic potential energy. In conclusion, elastic potential energy is the stored energy in elastic materials due to stretching or compression. It is important in understanding springs, rubber bands, bows, and many engineering systems. Elastic potential energy demonstrates how energy can be stored temporarily and later released to produce motion. That's all for my video. Thank you so much for watching.